On behalf of the University of Wisconsin-Stevens Point and the Wisconsin Department of Natural Resources, welcome back to our webinar series exploring prescribed fire for forest management. My name is John Schwingel and I'm fire manager for the Wisconsin chapter of the Nature Conservancy, and I'll be the moderator for today's webinar. A little bit about myself. For the Wisconsin chapter of the Nature Conservancy, I work across the state providing fire management, supervision, and coordination of our fire program, responsible for advancing the use of prescribed fire. The Nature Conservancy, on the Nature Conservancy lands, as well as partners on high priority resilient landscapes within the state. I joined the Nature Conservancy in 2020 after a 31-year career with the Wisconsin Department of Natural Resources, Division of Forestry, with extensive experience in fire management, especially in central Wisconsin. Our invited speaker will explore several facets of prescribed fire related to forests and forest management. They have been invited to provide their perspective and offer advice on how we can advance prescribed fire as a forest management tool for the future. We hope and we don't expect our speakers or anyone to have definitive answers about what the future will look like. Rather, we hope this series will provide insights, pose questions, and stimulate our collective thinking. Today, our focus will be on fire in northern pine systems. Before I introduce our guest, we have a few quick housekeeping items to review. Session recordings, additional resources, evaluation links, and information about continuing education will all be available through the portal. We will do our best to ensure the recordings are posted within 2 weeks of today's session. To receive continuing education, you must be registered through UW-Stevens Point, and you must complete the Microsoft form provided to you during the session. This link will be posted periodically throughout the day in the chat feature. If you're watching a recorded session, you will need to record your attendance using a different link that will be provided in the portal. If you have any questions, please email wfc@uwsp.edu. It's critical that everyone attending the live session or watching the recordings is registered for the series. This helps us with securing funding to continue offering free educational opportunities. We kindly ask that you do not share the portal, the Zoom link, or Zoom recording to someone not registered for the series. Thank you for your cooperation. This series is hosted by the Wisconsin Forestry Center at the University of Wisconsin-Stevens Point, the Wisconsin Department of Natural Resources Division of Forestry, and an evaluation link will be provided later this morning, and we will hope you'll provide feedback so we can continue to improve our series. For those of you attending live, though you are muted and we can't see you, we still want to hear from you. Please type any questions or comments into the Q&A function at the bottom of your Zoom screen. Please type any comments into the chat function of Zoom. The chat feature may not be monitored for questions, but our technical host is monitoring for content. We will do our best to address questions and comments, but may be limited from time to time. Before we begin today, please say hi and let us know where you're from. As of today, we have listeners from 44 states and provinces throughout North America and Europe. And last but not least, we sincerely appreciate our sponsors for making this opportunity free for all attendees. Today, we would like to highlight our platinum sponsor, the National Wild Turkey Federation, our gold sponsor, the Nature Conservancy, and today's silver sponsor, Heartland Ecological Group Incorporated. And now, it will be my pleasure to introduce Dr. Brian Palik, who is a science leader of applied forest ecology with the USDA Forest Service of Northern Research Station in Grand Rapids, Minnesota. He works broadly on questions related to ecological sustainability and adaptability of managed forests throughout use of operational scale and long-term silviculture research. So welcome, Brian. Thank you for joining us today.
Thanks, John, and thanks for the opportunity to be here and talk about this topic. So My perspective, as you'll hear, is really about thinking about the role that fire had in woodland ecosystems, and we'll use red pine ecosystems in the lake states as the case study. And then you all, those of you that work with prescribed fire, can be thinking about how to better utilize it in your work. So that's kind of what to expect. We're going to talk a little bit about the context, what I actually mean when I say a red pine ecosystem. We're going to talk about what we know now that we did not know before about the role of fire and how this ecosystem worked, and then how to advance your silviculture or your management to reflect that understanding. And again, my hope is that you'll get some idea of how you can generalize to other fire-dependent woodland ecosystems. So to begin, a little bit on context, what I'm talking about broadly is, if you speak land fire, is the Laurentian Acadian northern pine woodland ecosystem that occurred across the three lake states in the north. It's the kind of green blobs on this map, and also in southern Ontario as well. And in the U.S., that kind of ecosystem that had a strong red pine component prior to Euro settlement, pre-European settlement, was about 1 million hectares, so a lot. And then we can think about what it looks like today. That same kind of landscape position that supported that ecosystem, greatly reduced in area from about 1.5 million hectares to maybe 250,000 hectares. Overly red pine dominated in that it's oftentimes the only or the dominant species. High stocking, fire excluded often, not always, but often. And that leads to, particularly in Minnesota, and maybe not so much in elsewhere in the lake states, I'm told, but a dense woody understory of woody shrubs, and it's largely hazel here. And the bulk of that resource is actually plantation. So something that types out in FIA as red pine, 76% of that in Michigan, Wisconsin, and Minnesota is plantation. And why is that? Well, you can grow red pine to be a really high value product. And the way that's done is what I'll call timber focused silviculture. So this is kind of a generalizable prescription that's shown there in the middle, and not everybody does it this way, but the timber focused approach would look something like this: clear cutting, planting, perhaps several thinnings, at least one, and then a final harvest. And again, why is red pine grown that way? It's because of the value of it. Depending on who you talk to or where you look, 300,000 to 450,000 cords harvested annually across those three states. Cabin logs being the highest value product, but utility poles and saw timber as well. And the last thing I'll say here is that I say past belief in that I don't think a lot of people still think this, but when I was in school and coming up through the system of thinking about this ecosystem, that kind of silvicultural prescription was somehow thought to emulate natural disturbance dynamics. And what we know now, that couldn't be further from the truth, and we'll talk about that. So that's what I want to turn to next is, what do we know now that we did not know, or at least appreciate, say 30 years ago in ecosystems in the lake states dominated by red pine? Well, we know that red pine, one thing we know is that red pine occurs in some abundance in many different native plant communities, as we call them in Minnesota, habitat types, ecosystems. So this is just from Minnesota, state of Minnesota's Native Plant Community Guide. These are the ecosystems, there's 6 of them, that have abundant red pine, where red pine is probably the dominant species. So you can see there's a range of them there. And that's similar to what occurs in Wisconsin and Michigan as well. If you're from those places, you know that. So I would say that this is a busted myth, that red pine ecosystems are all the same. And really the context for that is, if we have a diversity of ecosystems, they're not all the same. They don't occur in the same place, in the same soils, etc. Probably we should have a diversity of management approaches for that species where it occurs. We should, but we oftentimes don't. as I just kind of pointed out. So what else do we know about that ecosystem? We know a lot more about disturbance regimes, particularly fire regimes, than we did back in the day. And much of what people thought we knew about for this comes out of this Heinzelman work in the boundary waters, and the interpretation of what he did were crown fires infrequently that were stand replacing, maybe 150 to 250 year interval for that, and then surface fires anywhere from 5 to 50 years. I will tell you, and many of you probably know this, Heinzelman actually never said this or showed this. It's a gross misinterpretation of other things that he talked about in his classic work, but it got applied to red pine, and that's what people thought about, and that's how it relates back to that silvicultural prescription. You see in Minnesota, this particular ecosystem I've listed, if you're from here, you know what this means, FDN 33A. It's the most abundant red pine dominated ecosystem we have in the north. And it's kind of a similar interpretation of that infrequent catastrophic fire rotation and then frequent surface fires. Well, what do we really know? And the funny thing is, what we know now, these people knew back in the day. So if you go back into this old literature, these folks knew that the fire regime in red pine woodlands was actually mixed severity, including less than stand replacing fire, and perhaps more often than not, less than stand replacing fire. We've actually done some work on this with Mike Stambaugh at the University of Missouri on quantifying that fire regime on the Chippewa National Forest, which is in north central Minnesota. And it's also, coincidentally, the Leech Lake Band of Ojibwe homeland. If you're not aware of that, it's a pretty unique situation where the reservation sits on top of the national forest, or the other way around, actually, the way it began. And Mike did reconstructions of fire across that landscape in red pine ecosystems. And that paper is cited there, you can look it up. But fire intervals ranging from 1 to 40 years, with a mean fire return interval for the whole landscape of 6.6 years. It's pretty frequent. And likely that range from 1 to 40 reflects variation in indigenous burning, both spatially and temporally. But then we have to factor in lightning caused fires as well into that. And there's similar work going on, has gone on, is going on in Wisconsin and Michigan, finding the same thing. So a different kind of fire regime. So the myth that's busted is that stand replacing fires define the disturbance regime. Probably not. I'm not saying it never occurred that way, but it doesn't seem to be the dominant regime. So another thing we know about red pine forests is that they were actually mixed species ecosystems. And so this, at the bottom, you see those species listed. This is, again, the dominant woodland type in Minnesota. There's 11 species there. And yes, maybe red pine was the dominant in terms of basal area, but you add up all the other species and they were more. And you can see examples of that kind of mixed species from the 3 lake states in those graphs. So the myth that's busted is red pine forests were mostly red pine. It might have been the dominant species in terms of abundance, but a lot of other species occurring as well. We also know, and I've been referring to this, that these ecosystems were generally woodlands with variable and open canopy. So these are the 6 red pine ecosystems in Minnesota, and I think those numbers are actually canopy closure. So you can see kind of low, mid to low, and variable. And why is that? Again, it's mixed severity fire regimes that included less than stand replacing fire. Also, note that we think about these as being driven by fire, but they're actually mixed agent disturbance. So armillaria, people think of it as a negative thing, but it's a native fungi, and it was probably important in terms of generating some structural and compositional heterogeneity, and then wind. So the busted myth there is that red pine ecosystems naturally were closed canopy, high density forests, the way they're managed often, but that's not what they look like naturally. So we also know that red pine ecosystems had really complex A structure, or they could. in that overstory was oftentimes present during regeneration events. And again, thinking that we had discovered something new when we started working on this, and go back in the old literature, these people knew that and they talked about it. Evidence for structurally complex age structures and stands. And then these photos come from the Chippewa National Forest, or what is now the Chippewa National Forest. And just the captions: nature's own group selection on the left. And then in the middle, patchy disturbance with red pine reproduction in groups. And then on the right, large old pines with red pine cohort regeneration. So that kind of reflects that structure that results from that type of disturbance regime. And we have looked at this quantitatively as well. We don't just rely on those photos and those descriptions. So what you're seeing here are establishment histories for red pine and white pine in 7 old growth stands in Minnesota. And then one of these on the right is that's on the Chippewa National Forest. We stem mapped those cohorts on each of those stands. And the point of this is that age structures were kind of variable and complex. So maybe you can call that's certainly a single cohort forest that I have circled there, but the establishment window is like 60 years. And then look at that. So it's probably 3 cohorts there. These are living pines that we sampled. And that's the one that's stem map there on the right. And you can see that the kind of spatial pattern of that is somewhat of a separation of cohorts in groups, so establishing in openings. And then what's that? It's a pretty complex age structure, maybe almost all aged. So again, regeneration establishing over decades, and that is not unique to Minnesota. These are examples from Minnesota, but people are finding this elsewhere in Michigan and Wisconsin as well. So the busted myth there is that red pine regenerates in even age stands. Single cohort, sometimes, like that top example, but not even aged. And then another feature is that, of course, old stands, you know this, old stands have big parts. So what you see in that table are those 7 stands, and it just shows the abundance of large diameter trees, large diameter snags, uprootings, volume of coarse woody debris, and it's all compared to that boxed at the bottom, which are FIA managed stands, which have a lot less of all that stuff. Now, that's not surprising, but the point I want to make here is that we're not really talking about old growth here or applying it to old growth. These are long live features that should be present in younger stands that have multi-cohort structure. So they survive disturbance. They're there in the new cohorts that regenerate. Okay, so to kind of summarize what we think we know now, how we put it together relative to the natural fire regime and resultant structure, mixed severity fire regime, including less than stand replacing fire, openings from these other disturbance agents, particularly armillaria, complex and variable age structures, mixed species, and then woodlands with variable canopy cover. And again, management rarely emulates that. So really, if you have a timber perspective or focus or goal that's part of your work, we tend to push these towards even age stands, spatially homogeneous in structure and composition, high stocking, favoring the A line on the stocking chart, if you're familiar with that. Generally short rotations, so 60 to 100 years. And yes, 120 years might seem like a long rotation, but relative to a lifespan for red pine and white pine, you know, that can push 300 years, it's not. In fact, we don't even think of that, as you'll see here in a minute, as being old growth yet. Strongly red pine dominated, oftentimes can have a dense shrub layer, at least in some settings, and then even age regeneration systems are typically what are used. And we talk about that approach leading to the triple S's in red pine managed for timber: structurally simple, spatially simple, and species simple. And certainly that's true of plantations, but it's not exclusively. Even natural origin stands that are being managed for saw timber or poles tend to get pushed this way. And you might be thinking, well, yes, timber stands are younger stands. You've just said that, Brian, that the rotations are short. So of course they display that simplification. And that is true, but our argument is they're too simple. So pine ecosystems had more complexity and diversity at all developmental stages, which we'll look at here in a minute. And that management largely truncates that development. So little structure is carried into the new stand, those old features that are long-lived that I finished up with there in a couple slides ago. So naturally, young stands or cohorts within those complex stands might have developed in a context like this, where you have them regeneration occurring, but it's in that context of a pretty complex, structurally complex stand. Okay, so now let's turn our attention to this, how to reduce the triple S's in all stages of development for this ecosystem. So what we'll look at here is a natural development model that ultimately can be applied to silviculture. And there's a lot here in this. We're not going to go through all this. I don't expect you to read it, but you have access to this talk and you can look at it. It's also the first place we published this was in this book a couple of years ago. So it's the red pine natural development model. And again, we actually talk about it in this book as a mixed severity archetype. So red pine woodlands as the case study for a mixed severity archetype that would apply to other types of fire-dependent woodland ecosystems. So it goes through these stages: disturbance and legacy creation. We'll look at some pictures of this in a minute, but pre-forest, young forest, mature forest, old forest. And here's the point I want to make, linking it to the theme of this webinar series, is that there are multiple points where fire likely occurred or could have occurred that are important for this development. And sometimes those fires would cycle back, say, mature forest back to the beginning, at least in a kind of multi-cohort structure, or sometimes it would develop that ecosystem into the old forest stage before it cycles back. And we'll look at this a little bit here. Again, remember the context for fire in this case. It's in these structurally complex multi-cohort kind of settings like this example. So if you're not familiar with this term pre-forest, it's a period of development, and I should say that those stages, obviously are continuous. They're not categorical. Here's one, and then obviously we're into the next one. They grade into each other. So pre-forest is after that disturbance, and it's a period where herbs and shrubs dominate. And this was kind of work that came out of thinking about Douglas fir, western hemlock forest, but we believe it applied here as well, unless our unique situation in the lake states is you can have this rapid development of aspen suckers after harvest in red pine if the parent trees are there, and we see that some. So you could bypass that pre-forest stage like this example here, but not always. Especially when you start seeing establishment windows for red pine of 60, 70 years, there's got to be other things that are important there. We don't manage for that, obviously. Young pine, young forest stage. Pines established slowly, as I just said, very slowly, actually. With lower stocking generally than what we tend to manage for. And then mature stage, this is where patch mortality starts to come in from fires that maybe are surface fires that crown out occasionally and kill patches of trees, or armillaria, like you're seeing on the right there, that are important for that patch structure. And then there's the old forest stage, which again, in our research and others in the lake states, tends to be multi-cohort, at least 2 cohort, large structures like you're seeing there, with regeneration occurring in that kind of context. So now let's think about how we advance our silviculture to reflect that understanding. So we talk about an ecological silvicultural system for the Great Lakes mixed pine ecosystem. And again, we published on it a couple places here. This this top one in 2023. I mean, I kind of refine this and tweak it over the last couple of years, but this is the most recent version of it that you'll see here, and it's in that book. And again, you can look this up because we're going to look at some tables here, and you can't read it all. But anyhow, our example here again is we frame it as applying to a mixed severity archetype, being other fire-dependent woodland ecosystems, particularly pine or conifer woodland ecosystems. So you can see that the developmental stages, that the prescription or the system is laid out to parallel those developmental stages, from disturbance and legacy creation, pre-forest, young, mature, old forest. We talk a little bit about duration, and one of the things you should note here is that mature forest, in our estimation of this, ranges up to about 150 years. So doesn't get old until after that, in terms of that old stage forest. And then we have some examples of silvicultural activities that you might pursue if you find a stand or have a stand in a particular condition. And then this is an important point of this. Here's where you might be thinking about where fire comes into play here, prescribed fire. So it isn't one time and you're done. There's a potential for 3-4 periods where you might be thinking about prescribed fire, which isn't the way that even people that you do use fire in red pine tend not to think of it that way. And then you can kind of see how fire relates to cycling back from mature back to initial disturbance event or transitioning into old. So we'll look at a few of these. We'll look at this one first, disturbance and legacy creation. What this really reflects on how we would do that if we're emulating that natural disturbance is variable retention harvesting, which is a partial harvest that leaves some aspect of the mature forest behind. And the idea is it better emulates natural disturbance and structural outcomes. You know, there's most of you, I'm sure, are familiar with this. It's been around a while, but not so much in the lake states for red pine. So for pine ecosystems, we talk about, as the name suggests, that it's variable in practice in terms of how you leave residual structure and the openings you create. So dispersed to aggregate and everything in between. The point is that some overstory is present after harvesting, just like those natural disturbances from fire appear to create in those examples we talked about earlier. So what you're seeing here in these photos are actual implementations of retention harvesting in pine. This is all in the Chippewa National Forest, but somewhat different patterns depending on the objectives and the stand. So, you know, it doesn't have to all look the same way, is the point. So if we go from there, the ecosystem is going to grade into a pre-forest setting. Again, a period of time, which, again, if you have kind of a aspen influx, could be really short, or it could be quite long, where something other than trees dominate the site. So herbaceous vegetation and some shrubs. We do not tend to manage for that. This is, you know, some of the people talk about early successional forest and how important it is for wildlife and birds, and it's this, but we like to point out that it's a period where trees aren't dominating. Then it's not to say there aren't trees there, but they're developing slowly in terms of establishment. So some of the things you might be thinking about during that time frame is site preparation, competition control, and this would be a point where prescribed fire would come into play, you know, sometime after the harvest, that you would bring it in like that. So, and then it is a period where regeneration starts to develop, but it's really in that young forest we'll talk about next where it gets going. And I will say that at least in our part of the world, where less prescribed fire in Minnesota anyhow is being used in red pine, there are surrogate approaches that people use to expose mineral soil, to reduce maybe woody shrub competition. And you know, the problem with this, that there aren't actual emulants of fire. They do some things the same, but the other things they might be doing are are disrupting root systems of overstory pines, for example, which fire didn't do. So it's not quite the same, but I'm aware that some of you probably use those surrogates. So then we would move into a young forest stage, and we talk about this in kind of a two-part: early young, say 5 to 30 years, and then later 30 to 70 years. Pointing out that we're calling that young forest, and it's a period of time where if you really have a strong timber focus for red pine, you'd be harvesting it by then. But that isn't exactly our approach. So some of the goals would be to direct development in these younger stands to create complexity, heterogeneity, and diversity. So reducing the triple S's. Some of the treatments involved are variable density thinning as opposed to row thinning, where you're trying to break up rows. And this is an example here in these photos from the Seney National Wildlife Refuge, where they've implemented that before and after. You might be thinking about enrichment, regeneration, getting species that are missing into there. And again, this may be a period where you're bringing in prescribed fire, particularly in the later part of this, where you're starting to bring it in to introduce that patch mortality, potentially even at 70 years. So that mature forest is where we move to next, and we define that again as 70 to 150 years. Some of the activities, you might use variable density thinning again in there. And there's an example in that on the right in that middle photo there where we have done that. With regeneration focused in the openings that you can see. You might have deliberate deadwood creation. You might be interested in competition control. Again, this is a point where prescribed fire would come into play in this mature forest setting. As a surface fire in particular. And then you might also be reintroducing a variable retention harvest into this. So if you have this, if timber goals are part of what you're trying to do, this would be a point where you might want to cycle back to the beginning here and cycle through young to mature. And that, that's fine if that's your perspective. And you see an example of that in the bottom photo. The last stage here is old forest, which we define as greater than 150 years, to get to the point where you're starting to get some of these old structures back in. And because we have so little of this on the landscape in the lake states, this old forest condition, probably if you're here, if you're going for that, your goal is to restore and sustain old conditions, not necessarily manage those for to have a timber objective included. So you might be thinking about deadwood and decadence creation if it's missing. You might pursue variable density thinning in that setting to create heterogeneity, regeneration in openings, competition control. Again, this would be a point where prescribed fire would come back into play. And you probably aren't going to do a variable retention harvest in this setting unless it's a high level of retention that you're trying to create there. So what I wanted to do, that's kind of the run through of our silvicultural system for this case study ecosystem, fire dependent woodland. And here's the pushback that over the years we often and still often get when we talk about this. And it's that you can't do that kind of syndrome, emulate that natural model for red pine that I've talked about. So you can't do that. Why? Because it puts regeneration in proximity to overstory pines. And yes, oh, my picture popped up before this. Yes, it does do that. So here's back to that example, that stem mapped old growth plot. Obviously, there's 3 cohorts of pine in there. They're old. But when they established, they were in proximity to overstory pines. And that photo in the middle is an example of us actually doing this, and you can see those regenerating red pine are in proximity to the regenerating overstory pine. And one of the concerns, the big one in the lake states or in places in the lake states, and I think this is an issue in the West. Well, I'm getting ahead of myself. That's the next one, next concern. But let's talk about this one. Impacts to survival and growth of intolerant species. Yes. So the intolerant species in particular people are concerned about are red pine and jack pine. So that's the concern with emulating that. And our answer to that is you can do that. You can regenerate those species in proximity to mature pine using a variable retention approach that is meant to better emulate the natural disturbance dynamic. And we've been studying this for a long time. This air photo shows a block from a study on the Chippewa National Forest that looks at different spatial patterns of retention. And they all were cut, the three that were cut, to about 72 square feet basal area per acre back in the day. And they're scheduled, they haven't been entered again, but soon to bring them back to that or even a little lower. And what you're seeing here in this graph are regenerating pines, its density of regeneration in a couple of different conditions here. So it says trees per acre. This is actually, you can think of this as survival over that 15-year period because we planted everything to the same density. So on the left-hand side of this is uncut forest. So it's the control. It's this uncut down on the bottom that you see in the air photo. Roughly 200 square feet per acre, a lot for a pine woodland, way too much. So that's on the left. And then on the right, our density of those three pines, red pine, jack pine, white pine, in what we call an aggregate retention large gap treatment. So that's the one that's listed on the top or shown on the top left of that air photo. Looks like a cookie cutter from the air, but on the ground, it's kind of cool looking. So they're 3/4 acre gaps and some thinning in between the gaps. And it was, again, cut to about 72 square feet per acre. Okay, so the left is pine survival, red, jack, white pine in the control uncut forest, and then on the right in the retention. And what you can see here, some of the things is that white pine doesn't care where it's at, it does pretty well in any kind of condition. The other thing I forgot to point out here is then each side is broken into ambient and reduced, and that's woody shrubs. It's mostly hazel, but not exclusively. It could be raspberry as well here. And so ambient is what's out there naturally after 100 years of fire exclusion or 80 or whatever. And then reduced is mechanically reduced, so just by brush saws over a few years. So again, white pine doesn't care, but the intolerant pines survive better in that large gap treatment. And it's not just the openings that this shows here. This is actually averaged across that whole stand condition for that aggregate treatment. So a big boost in survival of red and jack pine in that treatment as well. Then if you compare ambient shrub to reduced, an increase in survival of those two intolerant pines when you reduce that shrub competition as well. And that's survival. Growth shows the same thing in terms of the influence of that shrub reduction. This is showing jack pine diameter after 15 years on the left and red pine diameter after 15 years on the right in that aggregate large gap treatment. And you can see the influence that shrub reduction has on that growth. So shrubs matter is the point here, as well as the condition of that overstory treatment. And how were shrubs controlled naturally? Yes, fire. Frequent fires didn't eliminate them in the understory, but reduced their abundance and made them more spatially variable. And so by not having fire regularly in this ecosystem, we've kind of disconnected the ability to grow these intolerant pines in that sort of setting. So this is kind of an aside, but another myth is busted, is that jack pine is shade intolerant. We're taught that, right? It's very shade intolerant on the scale. It's actually intolerant of dry soil conditions, and it tolerates moderate shade pretty well. And this, our research that Rebecca Montgomery had led with us a number of years ago really showed that nicely. But it turns out those old timers knew that. If you go back in the old literature on pine regeneration, jack pine regeneration in the Lake States, people knew this, that red pine was more mid-tolerant, but it really doesn't like dry surface soil. So it's kind of an interesting thing that we're coming back to. Okay, so that was one of the reasons we're told we can't do that, emulate that natural model that leaves overstory pines in proximity to regeneration. The other big one, I jumped to this earlier, but I was getting ahead of myself. The other reason is this issue of overstory retention, shoot blight, and pine regeneration. So we have these two shoot blight fungi in the lake states. All our three native pines are susceptible, but especially red pine. And I'm told that, I don't know if it's the same species of fungi or not, but this is an issue in the West with Western pines as well. So if any of you from there, you probably know about this. And you can see that on the photo here, the bottom photo, are red pine seedlings that are infected with, I don't know which of these shoot blights it is in this case, but they're burnt, they're drying out, they oftentimes die. And a response to that you can't do that is you can do that. And again, this graphic shows it. So these are 15-year-old red pine and jack pine in this kind of setting of the aggregate retention treatment, in particular with reduced shrubs. So the things you can do to increase that survival potential, and shoot blights are in this study, in this stand that you're looking at, those numbers. There are things you can do. Retention in larger openings. So ours were 3/4 acre in that example, but half might be enough. So you're going to have less mortality of regenerating pines in those openings. And it's not that those seedlings probably aren't getting spores on them, it's that they're healthier in those openings and they're able to resist better. Shrub reduction. And the thought is lower humidity in the understory, less moisture stress, again, leading to their survival of pines, even when there's shoot blight present. The other thing I'll point to brings us back to fire. And Mike Austri was a long-time Forest Service pathologist that worked with us on this, and he talked about this in this paper. We don't have the data on it, it's just speculation that prescribed fire kills spores and reduces humidity. And our lack of regular use, like the natural model that I pointed out of fire, is leading to that increase in shoot blight where it occurs on the landscape. So the busted myth there is that the threat of shoot blight means you can never use retention in multi-cohort stands. And I get told this all the time, less so now that we start pointing out the results from these studies. So, oops, back up here a bit if I can go backwards. What I want to say at the bottom there, that box that came up, is you might be thinking that I'm dwelling on the past here. So I'm talking about the natural model and how we emulated it, and it's all from the past, and I get that. So let's think about this in the context of climate adaptation. And we've written about this a bit. Tony D'Amato, probably some of you know, and I did this paper, mostly Tony, and it's a really nice crosswalk between essentially what I've been talking about is an ecological silviculture approach, but can it be adaptation silviculture as well? And we work on this in this red pine ecosystem on an installation in the ASK network, Adaptive Silviculture for Climate Change. This is nationwide, and actually a couple installations in Canada now, but we were the first on the ground. It's on the Cutfoot Experimental Forest, which is on the Chippewa National Forest in north central Minnesota. We published a bit on it already. You can look at that. And the take home for that part of Minnesota is warmer in all seasons, a lot warmer in the growing season, prediction for the end of the century. And then drier growing seasons. Yes, maybe wetter or no change in precip overall, wetter in the winter, but not in the growing season. Pretty big reduction in drought is the concern. So that's the kind of context for it. And our approach to this, as all the ASK installations are, is we think about adaptation using the resistance resilience transition framework. And this is something Linda Nagel at Utah State and a bunch of us wrote about in Journal of Forestry a few years ago. And it's kind of the framework that all the ASK installations use, but we're applying it to this fire-dependent mixed species red pine woodland. And the idea here is you have gradients of impact and gradients of change. So resistance for us is to try to manage to enhance resistance to a stress, and it's drought that we're concerned about. And that woodland structure that we talked about, lower density, variably open canopy, that's reflective of that pre-European settlement ecosystem is actually an adaptation approach, because what we know is that trees grow better during and after drought at that lower density. And then resilience is restoring composition and structure, but within the natural range of variability. So some species, because of that, some of the native species may be more adaptable to climate change. In our case, it's eastern white pine, a couple of the oaks, jack pine. We also know that complex structures are more stable to some disturbances like wind. So again, falls within the natural range of variability. It's not what was always on the landscape, but it was in some places. And so that is an adaptation approach as well. And then there's transition, which really involves assist migration and thinking about adapted genotypes of native species, but also new species or novel species, but within the context of the natural disturbance model. So we might be bringing on more oaks, but again, within the context of that multi-cohort kind of structure. And the important point, bringing this back to fire, is there's going to be a role of fire regardless of the adaptation approach and where you transition to in terms of what that ecosystem looks like. Certainly in the first two, and likely in transition as well. And I don't know a lot about this. Many of you know more about prescriptions and burning windows than I do, but I would think if we're having drier conditions and longer growing seasons, that our opportunity to burn is going to increase as well. So it may become, in some sense, easier to do. Okay, so I'm going to finish up just summarizing. Red pine dominated woodlands were much different structurally and compositionally than their managed counterparts. And I think this is true for all fire-dependent woodland ecosystems that have kind of been transitioned into managing for timber objectives. In this case, historically, they were mixed species. They had much lower stocking, variably open canopy, complex age structures. Fire was a key to that dynamics and structures, but in ways that maybe you had not fully appreciated until recently. Silviculture for this ecosystem has rarely emulated that natural model, but as I tried to point out in the example, it can. And such a model would combine a variety of approaches. So variable density thinning, variable retention harvesting, enrichment regeneration, I'm calling it, getting the species, the other 10 species that are supposed to be in there back, and then prescribed fire at multiple developmental points. So not just cut it, burn the slash, plant it, and wait for it to get old. A natural model, including one that better embraces prescribed fire, does not eliminate timber objectives. That's not my approach at all, and I hope that nobody has construed it that way. Although what you grow and how you grow it will change. This isn't what we're pushing, isn't the way red pine is grown typically. And then last point I tried to make is that a natural model can be adaptable to climate change. So I've been talking, and you can see where I'm from. You can email me if you have questions. But if I've said anything that's of value or interesting, it's likely one of these people that are listed there said it first, because I've been referencing their work and their ideas as well. So with that, I am finished up.
Okay, fantastic. Thank you, Brian. Lots to think about. You know, I know from my perspective, working mostly in central Wisconsin, a lot of red pine plantation, and in a fire suppression role, fire was not viewed as being friendly to that timber management process in those areas. So this is fantastic to hear, to emulate more natural systems. Folks, we've got some questions coming into the Q&A here for Brian. If you put them in chat, I'm not monitoring that. If you wouldn't mind, or if you have any questions, a little reminder here, please put them in the Q&A section, and we'll tee those up. Brian, I've got a question here maybe to start us off with a question and answer session is, have you heard that fire plays a role in reducing red pine seed predation or predator populations? Is this true?
It's funny that somebody would ask that, because Tony D'Amato and I are actually writing a chapter for a book that others are putting together, and ours is on natural regeneration in red pine ecosystems and what we can do to increase it. And that I just found a bunch of old literature about that, about the role that small mammals have in particular in seed predation, and they don't talk specifically about prescribed fire reducing that, but it's hard to imagine if you make the link between fire and what happens to small mammals during them. I guess you can imagine that might be the case. So I've been thinking about it, but I don't have any specific examples of that.
Fair. We've got another question here from Ryan. What season was prescribed fire conducted? If in the spring, when related to green up, thinking about balancing wildfire risk versus burnability or flammability versus maximizing shrub control, especially when considering live conifer fuel moistures during that spring dip.
So the person asking that question is way more knowledgeable about how prescribed fire is done than I am. I'm not that guy, but you know, I know on the Chippewa National Forest they burn in the spring, and it's after partial green up, and it's a real short burning window. We have an old growth fire reintroduction study that we work with the National Forest on, and it's a pretty narrow window and opportunity to get fire back into that naturally. That paper I referenced from Mike Stambaugh that reconstructed fire regimes on the Chippewa, some percentage of them were in the late summer, early fall, which some people think that maybe was more common, but he did not find that from the chip fires. And again, you know, there's the role of indigenous burning in there that maybe was overriding lightning. So the seasonality is a little bit unsure to me. I will tell you that, and it doesn't have to just be fire. If you really want to knock back woody shrubs, hazel, you have to hit them just after they've leafed out, because they depleted their carbohydrate reserves and they haven't built them back up again. So if it's done after that point, it's not to say you don't have an impact, but it's a less of an impact. And that if you were to time that disturbance, whether it be fire to just after that leaf out, that will have the biggest impact.
Okay, appreciate that. I have another question. What is the difference between variable density thinning and variable density harvesting?
Yeah, good question. It's kind of a not all clear-cut differences, but variable retention harvesting is meant to be part of a regeneration harvesting system. So you're harvesting to create opportunities for regeneration in some form, but leaving legacy trees, residual trees behind. Variable density thinning doesn't necessarily have a regeneration component or goal to it. You are thinning, imagine a red pine plantation, rows of red pine, high density. Instead of row thinning it, you're thinning it in a way that creates variable spatial patterns of residual trees. So some openings, some skips, some thinning in between. And it doesn't necessarily have a regeneration component. I say it's not clear cut because some people do actually bring in regeneration into larger openings that in a variable density thinning approach. But the distinction is largely regeneration goal or not.
Appreciate that. We've got one from Jesse here. Lots of similarities with British Columbia mixed Doug fir stands and their management. Can you draw any specific similarities?
Yeah, so if you see my list of people like acknowledging at the end, Jerry Franklin is on there. And of course, he really started people thinking about emulating natural disturbance and forest management in Doug fir, Western hemlock, and colleagues of his as well. And so he is a colleague of mine, and that thinking translated into how I've been thinking. And Tony D'Amato thinks about this, and how we think about it in red pine here. So we started out as we're debating all these ideas with Jerry, thinking that red pine woodlands were, well, he tried to convince us they work the same way as Douglas fir western hemlock, but it took me a while to convince him they don't. So we talk about this mixed severity archetype, red pine being an example of that, whereas Douglas fir western hemlock is more of a another archetype we have is a catastrophic infrequent disturbance archetype. Not that there isn't retention of legacies after that catastrophic fire, but it's different in terms of how it plays out over time on the landscape. There is a western or a drier site component of Douglas fir western hemlock that seems to work more like these red pine woodlands, but the bulk of it maybe is a little bit different. So the similarities are that, and that we started out thinking about these as being similar, and then the differences are the differences in the two archetypes, the kind of the frequency of disturbance that creates regeneration opportunities is different.
Very good. Question here from Michael. Has there been work done on bird use of these variable density sites compared to normal plantations?
So, sort of for us anyhow, we have had bird work on our long-running variable retention harvesting experiment in the Chippewa National Forest, and this was done by Lisa Schulte, who is at Iowa State now and kind of has moved out of I think the bird world, but she had students working on this, and we didn't compare to plantations, but we compared to the control uncut sites, and there's a few differences that you create with those retention treatments that lead to more habitat diversity, like black-backed woodpecker. We found in that large gap retention harvesting treatment that it shouldn't be there according to the bird people, but in that part of Minnesota, but it seems to like that. So we have had some bird work done. You could look up red pine birds in Lisa Schulte or Minnesota and find those papers.
Okay, thank you. I have one here from Jeb. He's asking, can you extrapolate your results for pine to other species in the understory within the same ecosystem?
I'm not sure I completely understand that question. John, I don't know. Can you read it again?
Yeah, it disappeared on me.
Okay.
Maybe Jeb could tee that up with a little more clarity then. Here's one. Let's move to the next. Please recap on the 3 S's.
So it's just a, maybe not so cute way of talking about what a forest managed for timber objectives being kind of the driving factor. What we end up with are forests, particularly at young age, that are structurally simple, in that maybe it's just one age cohort, maybe that isn't old trees, maybe there's no dead wood. Spatially simple, in that there's no spatial heterogeneity of that structure. Again, I know everybody doesn't grow red pine plantations, but that's one of the bookends there. So think of a red pine plantation, and then species simple. So I tried to point out that these woodlands had 11, 12 species of trees that could occur in them, but we managed for, in that extreme case, 1 species. And that, it's kind of the norm in timber focused forestry everywhere, that we reduce, we increase the 3 S's.
Okay, wonderful. Juris has got a question here. Char on wood is not acceptable for paper mills making fine paper and food grade paper. Sawmills cannot sell charred chips to these paper mills either. Using fire in forest situations will limit what will be merchantable for forest products. I think that's more of a position or a statement from Juris.
It's an important one. We hear
Yes.
this a lot. This is a driving factor, at least in Minnesota, about why fire isn't used like that. There's a group from University of Minnesota, Cloquet Forestry Center, and I don't know if they published this yet or not, that have been gathering up information on how long char lasts after a fire. And I haven't seen the results of that, but I know people are talking about it. What I do know, and maybe somebody on this call knows this better than me. So our big buyer of pine in this part of the world is PotlatchDeltic. They make, dimensional lumber, 2x4s, and they cannot use that charred wood. The last time I visited the Huron National Forest, or it was actually the Manistee side in Michigan, they had very similar situation. And I think it was PotlatchDeltic as well, who did take it. And there was a process they used to wash their machinery and deal with that part of it anyhow. I know that's not the only thing, as the poster pointed out. So it is an ongoing issue that renders that regular use, like I've talked about, problematic. I don't have the answer to it, but I know that that's a concern.
Very good. Rachel's says here, we are using ecological silviculture principles to manage our old red pine plantation and where a wildfire has created nice openings. We hope to reintroduce fire, but landowners are tough to convince. We use tending/brushing in the meantime. Any tips?
Yeah, well, I'm really great to hear that's happening and you're doing that. We have studies where we use brushing as well to reduce hazel in particular, or raspberry or aspen sprouts. And again, one of the tips is timing. Again, doing it at the correct time to have the biggest impact. The other thing we found is it takes quite a few entries of that brushing to reduce shrubs to the point where hazel to the point where it's not really a factor anymore. So I guess the timing is one tip. Another is, probably be prepared to do it more than once, because once just makes that hazel mad.
Understand. Yeah, very good. I've got one here from Brad. Stocking guides have been developed for oak woodlands, incorporating openings and variability. Is there any work like this yet for red pine?
I am not aware of it. We have not done that. I'm not saying there isn't, but it's something that I've thought about and certainly needs to be done. It may be, you have a speaker down the road in this series, Jed Munier, who perhaps, because he is thinking about this in a more applied way than probably even we are, good question for him. But I don't know. But it is would be a useful thing.
Very good. We've got one here. You mentioned armillaria creating patches. Does it only kill the red pine, or are other conifers in the stand killed as well?
Well, where we're working on the Chippewa National Forest, again, for the reasons I talked about, the where we're working is largely red pine dominated. So where we see armillaria, it's on the red pine, but it may just be the fact that I don't think it's specific to red pine, but we don't have the other kind of mature conifers in those settings yet in the overstory to really assess the impacts to them. And so, other people I'm sure on the call know whether, what armillaria does to white pine or jack pine. So I'm not positive.
Okay, fair enough. Thank you, Jeb. He's back. Do you have data on how your management for pine affects that native plant species that coexist with those pine?
We have published some on ground flora plant communities, including herbaceous plant communities that are native, and from that red pine retention experiment. And again, that involved harvesting and brushing, but not fire. So it's a surrogate. It's not the same thing, but we do have that. We don't have it relative to the few places where we've actually had prescribed fire introduced to it. But you would imagine that if you have a system that's not been burned for 80 years, that, burned like every 6 years or whatever, that if those species are there that are fire dependent, they're going to respond favorably in some way. I don't know that for a fact, but that would be my hypothesis, that actually would be a good thing.
Okay, fantastic. And it looks like I've got one more teed up here from James. I'm not that guy either, Brian. I would say deciding the seasonal burn window would be dependent on multiple factors, the target species, regional fire models, if any, and maybe historic burns.
Yeah. Yeah, good points. I saw that comment pop up too, and it was good to hear that someone else doesn't think they're that guy. But we rely on the Chippewa National Forest fire people to help us figure this out in the old growth fire reintroduction study. And our primary goal there, I mean, all those things factor into deciding when the seasonality and burn window, but our primary thing is to reduce hazel, because you can't see across the understory of these what used to be open woodlands with all the hazel in there. So the timing we're pushing for is that kind of early or late to mid spring where hazel has just leafed out. And I don't know, there are other things that come into play deciding that, but that's the driving thing for us.
Okay. You're popular, Brian. We got a couple more here. There's one in chat that's being sent to me here. Let's see if I can bring up the whole question. While I'm doing that, from an anonymous attendee, are young red pine as fire resistant as older red pine? Or can the red pine regeneration be killed if you burn when it's too young?
Yeah, this person must be from the South with thinking about longleaf pine, where I did some work there. What a
Yeah.
unique thing where you can run that fire right over the seedlings and no big deal. Yeah, certainly young red pine is susceptible. And I looked at this up recently, what people think the kind of age size is where it becomes reasonably fire tolerant, or at least just mild surface fire. I don't remember what that was, but that is an issue, and that's where I put those fire icons, flame icons in. Is it in the later part of the early young forest stage or the older young forest stage where that might be okay to bring that in? But so there's that issue. But the other thing is, again, we think these fires are spatially quite variable. So we're not trying, I don't think the goal should be trying to, unless it's, a reduction of slash after a harvest where you might want to have a wide ranging fire. In those older conditions, I don't think you want to be burning the whole stand. You want to have skips where pine regeneration might be occurring and isn't burned. And that makes it way more complicated. Again, people on this call know this better than me. How do you do that? I don't know.
Yeah, appreciate that. Okay. Here's a question that went in the chat, but I got it teed up. Has anyone compared the economic difference between a variable density and a standard simple plantation?
I don't know. Probably people have. We have not in our work, and I'm not sure. I wouldn't be surprised if someone has. But here's one take on it that I like to point out to people. If we're standing in a red pine plantation that has had standard thinning, row thinning, the chip calls it free thinning, where they run down rows and pick trees, or a variable density thinning, the volume removed in that thinning is identical. So you don't lose in that first entry anything in terms of, and if it's a even age plantation, the trees are all going to be largely the same size. So it doesn't really matter where you get them from. You're harvesting the same amount. Now, over time, that kind of spatial heterogeneity you're introducing will start leading to, differential growth potentially. So there may be differences in growth and volume, growth and yield over time, but it won't be much, I don't think, as you're re-entering for a second variable density thinning. So if that equates into thinking about the economics, if the volume and the product size and class is identical, then the economics should be identical as well, at least in those early stages.
Okay, thank you for that. It looks like we've cleared the questions. I guess I would just like to say thank you, Brian. It's been fantastic. Thank you, everybody, for attending. That was extremely informative. I'm also reminded that in the portal, there is more research or more information that can be accessed. I think, Brian, you pointed toward that in some of your presentation, and can't wait to dig into that after the session closes here. Also note that coming up here in January 3rd, we've got Fire in Southern Pine Systems. This is our next webinar. You can see a QR code on screen. If you wouldn't mind, go ahead and take a snap of that and answer that evaluation. That's very informative and helpful for us for future sessions to try to meet everybody's needs. Again, thank you, Brian.
Thank you.
Okay, and with that, we can conclude. We've ended our session. Thank you all.